let's say welcome to the next speaker, who will give talks 4 and 5. Now we move to the University of Texas in Austin. And the talk is by Melina Knabe, first on parents and children jointly create multimodal semantic regularities during naturalistic toy play. Okay, give a warm welcome to the speaker.
Yeah. Okay. Hi, everyone. I'm excited to tell you about the work that I've done at UT Austin and understanding the kinds of multimodal input statistics children might use to learn semantic knowledge. So learning words is a really central task of early development, and the bulk of language development research has really focused on children's ability to link words to individual objects. But of course, children also have to learn the ways in which words and objects are meaningfully connected with one another to build a broader lexical semantic system. And we know that by about 18 to 24 months, children are sensitive to different types of semantic relations, such as taxonomic and thematic associations. But really a key question is how the semantic knowledge is acquired. And one solution that has been proposed is that children can rely on the statistical regularities in parents' speech. So the way that this is typically tested is by taking a large corpus of child-directed speech and then computing how frequently 2 pairs of words co-occur in a given window of time. And that window is then moved throughout the corpus, and these co-occurrence frequencies are then aggregated and used as a foundation to generate semantic networks. And it turns out that these models have shown that the distributional patterns in parents' speech alone are sufficient to build semantically organized word knowledge. But one limitation of this approach is that these models rely on extensive linguistic data that might not always be representative of what infants are hearing in their everyday environment. And so this takes me to our key research question, which is how children build semantic knowledge from their limited everyday input. And what we propose is another solution, which is that children rely on the multimodal input that they're jointly generating with their caregivers. Because parents aren't just providing speech in a vacuum, they're actively talking about what children are doing and seeing in the moment. And so what we suggest is that children can use their attention to objects in the moment to help them ground parents' speech and to link co-occurring words, using that as a foundation to build semantic knowledge from more limited input. And another benefit of this approach is that children might be able to link words that don't always co-occur temporally, but just by virtue of the fact that these words co-occur with the same object that they attended to across multiple different instances. Now the question is how children might be able to accomplish this, and we suggest that they can rely on cross-situational learning. So what cross-situational learning typically refers to is the ability of children to track how often words and objects co-occur, and then using these co-occurrence frequencies to make an inference about the most likely word for a given object. But what we suggest is that children might apply the same mechanism not just to learn individual word-object mappings, but also to learn what kinds of words co-occur, and using that as a basis to learn semantic knowledge. But then beyond that, they might not just ground and group words that co-occur with an attended object across multiple instances when they see that object. They might generally use the co-occurrence between words and objects to infer the semantic similarity between words. For instance, the idea that the words dog and cat tend to be heard when children attend to similar objects. And this might be used as a basis to begin to learn the semantic relations between these words. So our main research questions were to understand what kind of semantic information parents provide when children are attending to objects, and then secondly, to probe whether multimodal cross-situational learning might be a solution, or one solution, to how children build semantic knowledge from limited input. So the way that we tested this is we had 84 toy play sessions between parents and their 13 to 31-month-old infants. They had 10 minutes to play with 27 objects from 3 broad taxonomic categories. And they played with these toys in our home-like observational multimodal environment lab. I know that's a mouthful, but we call it Home Lab for short. It's meant to resemble a fully functioning apartment with a kitchen area, a living area, and a play area. So parents and children can interact more naturally, but nonetheless remain in a more controlled environment. Cameras mounted on the walls in this environment provide a third-person view of the interaction, but parents and children also wore head-mounted eye trackers that gave us a first-person view of what the parent and child were seeing moment to moment. We then annotated what toys children were looking at and also transcribed parents' concurrent speech. So to understand the kind of information parents are providing when children are attending to objects, we took our moment-to-moment data of where infants were looking and only looked at the moments where children were sustaining their attention on an object for more than 3 seconds. We then extracted the speech that they heard from their parents during that time period. So this could look something like that. So every time the child looks at the cat, we extract what they're hearing their parents say during that time window. And what this enabled us to do is to determine for each of the objects that children attended to what words they heard every time they saw that object throughout the play session. Secondly, what we could do is take all the instances where parents named a toy in our experiment and identify what objects they attended to when they heard that word. And we used these two approaches as a way to answer our 2 questions. Again, our first question was whether children hear more words that are semantically related to one another when they're attending to a given object across multiple instances in that play session. So here we calculated, so these cells right here just indicate how frequently a child heard a word when attending, for instance, to the cat. And we identified the proportion of time they heard the name for that object, so the proportion or the number of times they heard a word from the same taxonomic category, and the number of words they heard from a different category. And if we plot that, just the mean proportion of times that they heard a word from the same and different semantic category when attending to the same object across multiple instances, what we saw is that they were more likely to hear a word from the same semantic category co-occur. We also assessed this when children were not just attending to objects, but also holding objects, assuming that manual holding provides sort of an additional grounding modality. And we again see the same result. So children are hearing more words from the same semantic category co-occur during these bouts of multimodal attention to the same object. And they might be using these co-occurrence frequencies to more efficiently infer semantic relations. Our second question, again, was whether children can use how often a word co-occurred with different objects to infer the semantic similarity between words. So the way that we did this is we treated each word as a vector whose dimensions corresponded to children's attention to different objects. So here the cells indicated, for instance, what proportion of time when the child heard the word kettle, they were attending to the kettle object versus one of the other 27 toys. And we could use these, what we're calling attention-based word vectors, to then measure the similarity between any pair of words using Euclidean distance, which then resulted in this 27 by 27 matrix of these pairwise similarity scores. We could then apply multidimensional scaling to plot this matrix in a 2-dimensional semantic space. And what we see here are some semantic clusters emerge. And so what this suggests is that even if children have no prior knowledge, just purely relying on the speech that they hear when they're attending to objects might be a way to get semantic learning off the ground. However, children are, of course, coming to this task with some prior knowledge of the world. And so we also considered a hypothetical learner who brings some prior conceptual knowledge to the task. And the way that we were thinking about conceptual knowledge here, or the way that we operationalized it, was by computing semantic similarity scores between our items using ConceptNet. So if we were to plot that, we see these distinct semantic clusters emerge. So these are items that are more semantically similar to one another. And so when we were computing the similarity between our word vectors, we multiplied that by a value derived from our ConceptNet scores. So essentially what this does is if 2 items are more similar to one another based on ConceptNet, like cat and dog, it's going to pull these points closer together. We could then, again, generate the similarity matrix and then plot this in our semantic space. And here we see some strong semantic clusters emerge in comparison to the one that I showed you earlier. And so what this suggests is that the multimodal input alone is sufficient to get semantic learning off the ground, but this learning can further be accelerated as children are accumulating more knowledge of the world. Another semantic regularity that we assessed in our work that I don't have time to talk about in detail today, but it is in the proceedings, is that we also noticed that parents and children tended to play with objects from the same semantic category in close temporal succession. And this makes sense because they're creating sort of semantically coherent narratives. But we think that these bouts of semantic play might be really useful moments for parents to provide speech that's particularly semantically aligned with what children are actively seeing and doing in the moment. So really, the goal of this work was to understand how children acquire semantic knowledge from their limited input. As I mentioned, traditionally researchers have focused on speech input alone, but we suggest that semantic learning emerges from these multimodal input statistics that parents and children are jointly generating when they're interacting with one another. What we suggest is that children might use their real-time attention to objects to help them ground parents' speech and group co-occurring words and use that sort of as a basis to begin to get semantic learning off the ground. Children might also use these shared co-occurrences between words and attended objects to begin to infer how these words are semantically similar to one another. And so what this suggests to us is that multimodal cross-situational learning might be one solution to how children efficiently acquire semantic knowledge. And so what this really suggests is that if we ground parents' speech in children's real-time action and attention, that might be one explanation for how children learn given the limited input that they receive in their environment. And so with that, I'd like to thank the other co-authors in the lab, and I'm happy to take any questions as well.
So thank you, Melina, for introducing this interesting approach. And maybe we start with the questions up there to the... now we are again up there to the right, but maybe we could go to the left, up to the left. There were also questions. Okay, so we start here.
Hi, Melina. Really nice stuff.
Yeah.
So I was struggling, as you were talking, to think of an example of when I'm playing with my kids, I would mention the word cat when they're holding a dog, except in particular, this is like a thing. And I was wondering whether might be because, as you mentioned at the end of the talk, they tend to play with semantically related objects consecutively, which means that they're next to each other on the play rug. And I was wondering, because I know these eye trackers aren't perfect, if you had looked at the error with that. But then also, if they're playing with semantically related objects consecutively, then you've got temporal integration over time, so maybe it doesn't matter.
Yeah, that's a great question, or a great point. Yeah, even though this was an unstructured activity, so it was free-flowing, we do see that parents and children are creating these narratives. So that might explain why they would hear cat and dog in close temporal succession. We do find instances, though, that even if they're not engaging in these temporal sequences, they're still referencing another object. And again, that could be a function of this activity because they're sort of referencing something that they talked about earlier and interacted with earlier. But I think a question that is sort of coming out from your question is like how this might generalize to other interactions that infants might be having. I think in everyday interactions, parents and children are also in broader semantic contexts. And so in that sense, there's sort of that additional information embedded. So if you're in the kitchen or in the bathroom, all these items are going to be more semantically related. And in fact, that might, even if you're not having to create narratives, just by virtue of the spatial context you're in, you see sort of related words and objects co-occur. Yeah.
Okay. So.
Yeah, thank you. Quite interesting. I was wondering how you see this playing with ideas around universal grammar and also there's kind of potentially spurious correlations that occur. So like a dog, the toy of a dog might be brown all the time, but presumably the child doesn't think that dogs are always brown, right? There's some sort of grounding that happens beyond that. So I'm wondering how you see maybe those two interacting. You said narrative might be one option, but yeah.
Yeah, sorry, can you clarify one more time?
So sort of the relation to how do you pick out the meaningful relations and how does that maybe play with universal grammar and not just statistics, so.
Yeah, I don't think I have a direct, I'll have to think more about your question. I don't have a good answer at the moment. I think something that we're of course not looking at here because you're talking about a dog having sort of very specific features. Of course here these are only single exemplars of these items. And so something that we could also look at that we haven't is sort of the perceptual similarity between items as well. That's something that we're sort of completely omitting here because we're only focusing on like the words that children hear. Anyway, I don't have a good answer to your question. Maybe we could talk more about it,
Sure.
later as well. But.
I think we have time for one more question here in the front. We have one here. Okay.
Hi, thank you so much for the talk. I'm curious if you might see like the structure of their attention also following similar structures that you find in these semantic networks. Like if like perhaps I'm saying dog and then I say cat, is that going to then shift the child's attention, to the cat and kind of create these like, I don't know, bouts of play that follow similar structures as these semantic structures? I don't know if that is a thing they're considering looking at.
Yeah, we haven't looked at it in that way. What we have done, and that is also in the proceedings paper, is looked at the transition probability in infants' gaze, and we do find that they tend to look to objects from the same category, or they're more likely to look to an object from the same category in sequence than others. Of course, that's coupled necessarily with speech as well, but we haven't necessarily looked at, if a parent talks about dog and cat, are they more likely to then quickly orient to the cat if it's more semantically related? So there are a lot of open questions to ask in this data, but yes, definitely.
Okay. So thank you for this talk. And